Hello my dear students. Today I am going to start organic chemistry chapters for second semester students. The first chapter in organic chemistry is aromatic hydrocarbons. In the previous semester you studied some of the aspects of aromatic hydrocarbon. There you studied meaning of aromaticity and different types of aromatic compounds and Huckel's rule, criteria for aromaticity, and some of the chemical and physical properties of aromatic compounds you studied in the previous semester. In this semester, under this chapter, aromatic hydrocarbon, we are going to study only about benzene and benzene derivatives. Mainly in this chapter, we are going to discuss three important concepts. One is preparation of benzene and electrophilic substitutions of benzene, and finally oxidation of alkyl benzene. We are going to study these three concepts. So let us start one by one. Preparation of benzene. So before going to discuss preparation of benzene, I think in the laboratory you have seen benzene. So we are stored in a brown color bottle. So benzene usually it is a colorless liquid. It's a colorless liquid. It's a liquid in room temperature, and its melting point is 5.5 degrees Celsius. That is, if you decrease the temperature below 5.5, it is exist as a solid, and its boiling point is 800 degrees Celsius, and it has harsh smell. It burns with eye smoke if you done flame test. And the main source of benzene we obtained from petroleum industry, and it's a non-polar solvent, but we are not going to use it as a solvents. Even though it shows solvent properties, we are not prefer benzene because it is toxic, it is carcinogenic in nature, that is it causes cancer. Because of that, instead of benzene we are going to prefer toluene. These are some of the physical properties of benzene. Next, preparation of benzene. Because of its uses, we are going to prepare benzene in the laboratory. We can prepare benzene in 5 methods. The first one is we can prepare from benzoic acid. We can prepare benzene from phenol. We can prepare from diazonium salt. We can also prepare from acetylene and Grignard reagent. Let us see one by one. The first method of preparation of benzene is acetylene. So you know this acetylene. So this is a common name of ethine. You know the formula of ethine. So CH triple bond CH. This is ethine. And you also know that this acetylene is also used as a chemical for ripening of fruits. This acetylene can be used to prepare benzene through cyclic polymerization. You know linear polymerization. So that is many number of monomers undergo repeated combination to produce a linear compounds. Like that, these acetylene molecules undergo cyclic polymerization to produce a cyclic compound, a 6-membered ring called as benzene. That is when you pass this ethine in a red hot tube of temperature 873 Kelvin. So this converts into benzene. Let us see the reaction. So let us take 3 ethine or acetylene molecule. So when these acetylene molecule passed on red hot iron tube at 873 Kelvin, you are going to get a benzene, a formula C6. Yes, this is an example for additional polymerization. That means there are 6 carbon, 6 hydrogen completely undergo cyclization, that is cyclic polymerization. It gives benzene. This is the first method. So it's a very simple method through which we can prepare benzene. Second method is we can prepare benzene from benzoic acid. Benzoic acid. that is when benzoic acid is treated with sodium hydroxide. Base, benzoic acid is an acid. To test an acid, we are going to do test with sodium hydroxide. That is, if you take benzoic acid solution and to that add sodium hydroxide solution, if it is dissolved, so it indicates, so it is a first step. So if anything, if you decide or confirm whether it is an acid or base or an acid, you must dissolve that with a base. Then only this is not a good method. There are many methods are there, functional group test and litmus test, but this is a basic reaction through which we can identify the acid. So this is a benzoic acid because it has COOH group. This benzoic acid on react with sodium hydroxide, it gives sodium benzoate. Then the sodium benzoate further react with soda lime. You just observe this reaction. Okay, first this benzoic acid react with the sodium hydroxide. Here O minus H plus. So this H plus is replaced by sodium, and this H plus combined with this OH minus ion, it give water. And the Na plus combined with this O minus, it gives COONA. So this is called as sodium benzoate. This molecule is called as sodium benzoate. This sodium benzoate further react with soda lime. Soda lime is nothing but the mixture of sodium hydroxide and calcium oxide. Calcium oxide and sodium hydroxide is called as soda lime. This sodium benzoate on heating with soda lime, it gives benzene and sodium carbonate salt. You just look at here. In this reaction, what happened? If you heat with soda lime, at that moment, this COO group is eliminated from this sodium benzoate. That's why this reaction is called as decarboxylation reaction. The reaction which involves the removal of carbon dioxide, so that reaction is known as decarboxylation reaction. The decarboxylation takes place when you heat with soda lime. That is, when you heat with soda lime, so here there are two sodium, Na2 and CO3, Na2 CO. So you are going to get sodium carbonate. You are going to get sodium carbonate. So this is the byproduct in this reaction. So this is very simple, dear students. From benzoic acid, so first they are going to treat with base, it gives sodium benzoate. Then on heating sodium benzoate with soda lime, it is a mixture of sodium hydroxide and calcium oxide. So you are going to get what? This benzene and sodium carbonate. This is the second method of preparation. Let us see the next method, benzene diazonium salt. So these diazonium salts have very good synthetic applications. By using this diazonium salt, we can synthesize many compounds, and this diazonium salt, it gives good synthetic synthetic link to synthesize many organic compound containing different functional group. So in that sense, so we are going to prepare the benzene, the compounds of benzene by using diazonium salt. So first you must know how to prepare diazonium salt. This diazonium, the name itself indicate it contains diazo group. So in chemistry, if anything molecule containing nitrogen, N double bond N, this is called as azo group. There are two nitrogen, that's why it is called as diazo group, that is benzene diazonium chloride. So before going, now let us see the preparation of benzene diazonium chloride. So aniline is a fishy odor compound. When aniline react with nitrous acid, dear students, if it is HNO3, it is nitric acid, but it is HNO2, so HNO2 nitrous, oxidation of nitrogen changes, that's why the name also changes. This is a nitrous acid and this is nitric acid. Here aniline is react with a mixture of nitrous acid and HCl, it gives, so at 0 degrees Celsius, I think you are going to do this step in the laboratory. You are going to prepare this diazonium chloride in the laboratory. So there you are going to take aniline. So you are going to keep the aniline in a cold condition, and you are going to keep this mixture, reaction mixture, in a cold condition. Then you are going to mix, and you are going to run the reaction in a cold condition. You are going to get the product. So this is called as benzene diazonium chloride. You look at the composition of the benzene diazonium chloride. So here to the benzene, two N are directly attached. The structure is like that: N double bond N Cl. This is a salt. So N plus Cl minus, and this is directly attached to the benzene ring. So this moiety attached. So this is called as benzene diazonium chloride. So by using this benzene diazonium chloride, we can prepare the benzene derivatives. So now let us see the benzene derivatives by using benzene diazonium chloride. You look at here. You look at all the reaction, dear students. This is the benzene diazonium chloride. So, and this benzene diazonium chloride contains this N group, N2 group. You know, nitrogen gas, it's a stable gas. So because of that, this N2 is a very good living group. That's why we prepared this group. And this reaction is called as Sandmeyer reaction. That is the reaction which involves the preparation of benzene derivatives by using benzene diazonium chloride. So this is called as Sandmeyer reaction. Let us see the reaction. So first take this, when benzene diazonium chloride is react with the CuCl, cuprous chloride in HCl, it gives chlorobenzene, and it liberates nitrogen gas. See the reaction. So if you react cuprous chloride, it gives chlorobenzene, and N2 gas get liberated. And if you treat the same benzene diazonium chloride with cuprous bromide over hydrogen bromide, it gives bromobenzene, and it liberates N2 gas, and it gives Cl minus ion. And if you react the same benzene diazonium chloride with the potassium iodide, you are going to get iodobenzene, and it liberates N2 gas and chloride ion. And this, the same benzene diazonium chloride on treat with sodium nitrite. So this is nitrite. If it is NO3, this is nitrate, but it is NO2. So that's why it is, if it is NO3 minus nitrate, here sodium nitrite over fluoride. So at this temperature 272 to 278 Kelvin, that is less than 0 degree Kelvin, so it is going to give fluorobenzene, plus it liberates nitrogen gas, and it gives boron trifluoride. So dear students, you just look at here. We are just changing the reagents. If you just change the reagents, so you are going to get different product. If you add cuprous chloride and HCl, you are going to get chlorobenzene. If you add cuprous bromide, you are going to get bromobenzene. And if you add potassium iodide, you are going to get iodobenzene. And if you add sodium nitrite over hydrogen borofluoride at this temperature, 278 Kelvin temperature, you are going to get fluorobenzene. This is also called as Sandmeyer reaction. He is going to synthesize these reactions in the laboratory first time. That's why this is named as Sandmeyer reaction. Next method, by using phenol. By using phenol also we can prepare this benzene by using zinc as a reducing agent. You know reducing agent? Reducing agent is a species. It is helpful for reduction. It is helpful by taking oxygen. Now let us look at this reaction. If you eat phenol with zinc dust, so zinc dust is a well-known reducing agent. It gives benzene plus zinc oxide. Dear students, it's very simple. Here zinc acts as a catalyst. It is a catalyst used for reduction. If you use zinc, this zinc takes this oxygen and it becomes zinc oxide, and this hydrogen which is remain in the benzene ring, and it gives benzene. This is a one simple method through which we can prepare benzene by using phenol. Now the next method of preparation is preparation by using